Okay, so we're going to be talking about mutually exclusive events today. That's what our goal will be. So again, we're gradually increasing the complexity of these questions. So as I've said before, if you're not getting extra help, not doing the work, you're definitely going to notice and you're going to feel like you are lost. So we're going to look at eye color, green or brown. What is the probability of randomly selecting a student in this class with green eyes? Well, today, how many students do we have in this classroom right now? Somebody count for me. Not a lot. 2, 3, 4, 5. Thank you. I have 12 students in this class. So I want to find out how many students, how many of you have green eyes? Raise your hand if you have green eyes. 1, 2. So my NA is 2 students. So the probability of selecting a student with green eyes would be what? Billy, can you help me out? Good, which reduces to what, Pat? Good, 1/6. You have a 1 in 6 chance of picking someone in this class with green eyes. What is the probability of selecting a student in this class with brown eyes? Well, again, my NS is still 12 because there are 12 of you here today. My NA is how many brown eyes there are. So who's got brown eyes? Raise your hand. Okay, count for me. 1. Are you raising your hand, Dylan? Pardon? Okay. How many? 7? Okay. So the probability would be what, Mike, for picking someone with brown eyes? Good. 7/12. And then that can't be reduced, so I would leave it like that. Now, if the next question here, it says, what is the probability of randomly selecting a student in this class with green and brown eyes? Does anyone see a problem with that question? Can you have both green and brown eyes? That's Hazel. Some people do. The chances are you can't, an eye color may not be the best example for this, but you can't have green and blue eyes. There are some exceptions to that where people have 2 different colored eyes, but you can't really classify yourself as having green and brown eyes. If you were to talk about one color your eyes being, so the probability here of green and brown would be equal to 0. You can't have that at one time. So I have here, what is the probability of selecting a student in this class with green or brown eyes? So again, and is different than or. If I want the probability of green or blue, Spencer, what do you think you would do for this? Very good. So I would take the probability of the green. I'm going to add it with the probability of the blue. And what I'm going to do here, what students usually forget, is you're going to subtract the intersection of these two. So the green and blue. We don't have that, but in another case you would. So we're not over counting. We're not counting that overlap. So the probability of green was what, Scott? 1/6. And the probability of blue was what, Powell? 7/12 minus the probability of green and blue, which is 0. And what do I get when I add those two up? David? Yep. So you have a 9 in 12 chance of selecting someone that has green eyes or brown eyes. Any questions with that? Okay, so then it talks about the definitions. And again, I don't know what's wrong with this. So it says these events are mutually exclusive since there's no intersection between the groups, i.e. you cannot have green eyes and brown eyes, only one or the other. Mutually exclusive events, so again, this is the union. So where you take the probability of A plus the probability of B and subtract the probability of both. So if we were to look here at what mutually exclusive events look like on a diagram, a Venn diagram, I have green here, which I had how many students? 3? 2? So I have 2 students here, and I had how many, did I have 7? 7 students with brown eyes. So there's no overlap. That's what we call mutually exclusive. They're by themselves. So what does that say if we have 12 students in this class? What do we say? Right now I have 12 students. 2 students have green, 7 students have brown. What can you say? If I take 12 minus 9, so that's my total students here today, minus 9, where did I get 9 from? The green and the blue, gives me 3. So 3 students have some other eye color. Now, technically what you can have is we have a rectangle here. What you could do is you could put the 3 down in the corner if you wanted to, because that represents all the people inside that set. And we know we have 2 green eyes, 7 brown eyes, and 3 is just here to say 3 have some other color eye that we don't notice. And again, if there's no overlap, the sets are said to be disjointed, which means that they're mutually exclusive. Okay, so we're going to now look at 2 other features, hair length and blue eyes. What is the probability of randomly selecting a student in this class with long hair? Okay, so again, I have 12 students in this class. How many have long hair? Raise your hand if you would consider yourself having long hair. Do you consider yourself having long hair? Okay, Joanna's got long hair. Spence? Okay, so we're going to say 2 students have long hair. Okay, so the probability of this would be what? Ben? What is the probability of randomly selecting a student in this class with long hair? Good, which gives me what, David? 1/6. What is the probability of selecting a student in this class with blue eyes? So we talked about this. We already know what our blue eyes are. The probability of, oh, no, we didn't. My NS is still 12. My NA, how many of you have blue eyes? Raise your hand. So we have 3. So my probability of having blue eyes would be what, Dylan? 3/12, which can be reduced to what, Noah? One over 4. Okay, so what is the probability of randomly selecting a student in this class with long hair and blue eyes? So out of my 3 people who considered themselves with long hair, how many of you have blue eyes? This is not a good example. So how many, I'm going to change blue eyes to brown eyes. So maybe it works a little bit better. So how many people have long hair and brown eyes? Okay, so I have 2 here. So I'm going to write the probability of long hair and blue eyes is 2 out of 12. Oh, yep, thank you. Okay, which is 1/6. So then it says, what is the probability of randomly selecting a student in this class with long hair or, I'm going to change that to brown eyes. Okay, so in order to figure out the probability of this, it becomes the probability of long hair or brown eyes. So in order for me to find that out, I take the probability of having long hair, I add it with the probability of brown eyes, and I subtract it with the probability of having long hair and brown eyes. So we're getting rid of the overlap people, so we're not counting them twice. So if I looked here, the probability of having long hair in this class was 1/4. Plus the probability of having brown eyes. What was my probability of having brown eyes? 7/12. Minus the probability of having long hair and brown eyes, which is 1/6. So when I put all of that in, everything into consideration, Pat, what do I get for a final answer for the probability of long hair and brown eyes? Pat, what'd you get? How'd you get that? You would have gotten 8/12, right? 9/12. So we get 9/12, which absolutely gives us, it should give you 3, and multiply by 3, 3 plus 7 gives me 10/12. Oh, minus, yeah, no, it's 8/12. Sorry. Yeah, it's 8. Which is 2/3. Thank you, Pat. Okay, so I have a 2 in 3 chance of selecting someone who has long hair or brown eyes. Does anyone have any questions with that? Okay, we're going to go, it says here, these are not mutually exclusive since there is an intersection between the groups, i.e. you can have blonde hair and blue eyes at the same time. Events that are not mutually exclusive, so again, I'll just get you to fix this notation. The probability of selecting A or B equals the probability of A plus the probability of B minus the probability of A and B. So when I did this, so my Venn diagram here, so I'm going to have long hair in one circle. We'll have brown eyes in the other circle. So we had here, how many students did we say had long hair? 3? 2? Ooh. So I always start with the intersection. My intersection, I can't remember the numbers. I have a bad short-term memory. The intersection was I had 2 students with long hair and brown eyes. My brown eyes, I originally had 9 students, right? Can you guys check your numbers for me? 7. So here I'll have 7 minus 2 gives me, so I have 5 students with just brown eyes. And my long hair, how many people originally said that they had long hair? 2. So what would I write in that final circle? 0. Okay, and then I can use here figuring out the or, how many people have long hair or brown eyes. All I would do is I would just add up all of the sections here. So it would be, I could take so the probability of long hair or brown eyes is equal to, and then I can just take 2 plus 5, which gives me 7 over the 12. Have blue hair or brown eyes and long hair. Okay, if there's an overlap, the set is said to be jointed. Wonderful. Okay, the next one, it says, no, mutually and non-mutually exclusive refers to meeting 2 criteria for the same action, not 2 separate actions. Okay, so we're now going to be talking about dice. You're going to see a lot of these types. So it says here, you roll a single die once. What is the probability that either a 3 or a 5 is rolled? What do you think you would say for that, Mike? Okay, good. How did you get that? Mm-hmm. Okay, so I can look at this. The probability of rolling a 3 is what? 1 out of 6. Or means I add the probability of rolling a 5, 1 over 6. And again, if I'm using this mutually exclusive, non-exclusive, I would then subtract the case of rolling a 3 and a 5. We can't roll a 3 and a 5 when we're rolling the dice, so that's like saying 0. So Mike's absolutely correct. I have a 2 in 6 chance, which is a 1 in 3 chance of rolling a 3 or a 5. Are we okay with this? So it says you roll a single die. What is the probability that it will come up either an even number or greater than 3? So I'm going to jot down these numbers here. 1, 2, 3, 4, 5, 6. Those are the dice. So I want the probability of an even number, or it has to be greater than 3. So again, if I break this up, I'm going to find the probability of an even number plus the probability that you're greater than 3 minus the probability of the intersection of even and greater than 3. So, Spencer, can you help me out here? What is the probability of me rolling an even number? Good. 3 over 6. This is even, even, even. Plus the probability of rolling greater than a 3. Scott, what's the probability of me rolling a number bigger than 3? Good. This is greater than 3, greater than 3, greater than 3. So I have plus 3 over 6. Now I have to minus the intersection. So what is the probability of rolling an even number and that it's greater than 3? Powell, what would you put for that? Good. Here, this is an even number greater than 3, an even number greater than 3, so I subtract that because I'd be counting that twice, which leaves me with the final answer of what, David? Very good. It's no. So we're looking for even number and greater than 3. So we don't include the 3 for that. Is that what you were asking? Yeah, no, we don't include that. So it has to meet that 2 criteria. It meets one of them, but just not the greater than 3. Okay, so next we're going to go to a card example. A card is randomly drawn from a standard deck. What is the probability that the card is either a face card or a spade? So again, the probability of a face card or a spade. I will take the probability of a face card plus the probability of a spade, and I minus the intersection of the two because I don't want to overcount. So the probability of the face and the spade. So Joanna, what is the probability of me getting a face card? Very good. Ben, what is the probability of me drawing a spade? Very good. Minus the probability of drawing a face card and a spade. David, how many face cards are there that are spades? 3 over 52. So when I add all of that up, Noah, what do I get? Good. Which reduces to 11 over 26. Okay, do I have any questions with this? Okay, the next example here, it says, in a recent survey of university students, 85% consume alcohol at least once a week, 35% smoke cigarettes at least occasionally, 25% do both. What is the probability that a university student chosen at random smokes or drinks? So this is dealing with percentages. So I'm going to, again, I have 2 circles here. So I have drinks and smokes. What will I start with when I put this in my, what's the first number I'm going to put in my Venn diagram? Billy, can you help me out? Good. So 25% of students, university students, go in the middle. Pat, can you give me a number, another number to fill out in my Venn diagram? Which gives you 10% of students smoke. Mike, can you fill in the last number there? 60. Okay. So what I have here, when I want to find what is the probability that a university student chosen at random smokes or drinks, so I'm going to have here the probability of this, of smoking or drinks. Okay, the probability of smoking or drinks. What do I have to do here based on this Venn diagram? How? Why do I add them all up? I actually end up adding all of them together. I do 60 plus 25 plus 10 gives you 95% of students, because this is given in percentages. You have to remember here that we started with the 25% of students do both. So they would raise up their hand, this 25%, if I ask you, okay, how many of you university students, how many of you drink? They would put up their hand for drinking. And then they can also put it up for smoking. But we've also subtracted them from the ends here. So because we're dealing with percentages, we add them up. So it's a little bit different when we're talking about percentages versus the actual numbers. So for the percentage for smoking or drinks is just 95%. Okay, you will have to recreate this. This is not difficult. We're going to use, we have dice here. So on my chart here, this would be considered dice 1, rolling a 1, 2, 3, 4, 5, 6. This would be dice 2, rolling a 1, 2, 3, 4, 5, 6. What we're going to talk about is the sum of a lot of these dice. So if I fill out this chart here, which we're going to be making reference to a bit, if I roll a 1 and a 1, what's my sum going to be? 2. If I roll a 2 and a 1, what do I get? 3. You'll see it goes 4, 5, 6, 7. I'm taking each one of those yellow die and I'm adding that number with a 1. On my next column here, Spencer, can you help me out? What am I going to fill in my next column here, my next row? Keep going. Very good. And my next row, Scott? Good. My next row, Powell? Good. My next row, David? Good. My next row, Ben? Okay, anyone have any questions about coming up with these numbers? Okay, so now you're going to have to recreate this because it is helpful to see on your test and on your final exam. It says here, what is the probability of rolling a total of 10 with 2 die? So the first thing I need to figure out, my NS. How many total options do I have when I roll 2 die? Joanna, can you help me out? Good. David, what is the probability of me rolling a 10? 3. So the probability of rolling a 10 is what, Noah? Pardon? 3 over 36, which is saying you have a 1 in 12 chance of rolling a 10. Okay, then next question. What is the probability of rolling a total of 4 or less? The number stays the same. I can still roll 36 different combinations. My NA would be what, Billy? Less than a total of 4 or less. Very good. So how did Billy get 6? So it's saying a 4 or less, so that means I'm including this 4, 4, 4, and anything less. So there's 6 numbers there. So what would I write for the probability of rolling a 4 or less? Pat? Excellent. Oh, I shouldn't put A. We would say less than or equal to 4. Okay, the next question relating to dice. What is the probability of rolling a 10 or a total of 4 or less? Okay, so for this one here, Okay, but I want you to get into the habit of the probability of rolling a 10 or less than or equal to 4 would be saying find the probability of rolling a 10. I add it with the probability of rolling less than 4 minus the probability of rolling a 10 and a number less than 4. Okay, now that last part, it absolutely makes no mathematical sense, which just means that there's 0. So intuitively, Ben, you're doing the right thing, but there are going to be some examples where you have to throw in that last part there. So I want you to just get practice writing it. So the probability of rolling a 10, we said was 3 over 36. I add that with the probability of rolling a number less than 6, which is 6 over 36. And I minus it, the probability of rolling a 10 and less than 4. Well, that's impossible. You can't roll a 10 and have it less than 4 because 10 is greater than 4. So that would be saying 0. So my total probability would be, what, Mike? Which is, okay, I can do 9 over 36, 3 over 12, which is another way of saying 1 over 4. Okay, the next example. What is the probability of rolling a total of 10 and a roll with a 4 on one die? So I want the probability of rolling a 10 and it has to have a 4 on one die. So if I look back up at my chart, my 10s are here. 10, 10, 10. Can I get a 10 with having a 4 on one of the dice? And if so, how many times does that occur? It occurs twice. I can have here my yellow die, there was a 4 with a green 6. I can have a yellow 6 with a green 4. So there are two options so that I can roll a 4 to get a sum of 12. So I would have this as 2 over 36, which is another way of saying 1 over 36. So what we can do here, just to show you a picture, if this is my die 1, I can roll a 4. And my second dice, I can roll a 6. Pardon? Yes, thank you. And then on the same one here, I have the dice, I can roll a 6. And then on my green die, I can roll a 4. So that's why there are two ways. Okay, so when our final question of the day is, what is the probability of rolling a total of 10 or a roll with a 4 on one of the die? So as soon as you see this OR case, again here I have the probability of 10 or the die of 4 is equal to, so I would write this out, what's the probability of rolling a 10 plus the probability having a die of 4 minus the probability of a 10 and a die of 4. So Spencer, can you help me out here? What would I put in for the probability of rolling a 10? Three over 36 plus the probability of rolling a die with a 4 on it. Not 2 over 36. What is the probability? Okay, so let me read this again. What is the probability of rolling a total of 10 or a roll with a 4 on one of the die? So all I'm looking at, the probability of having a 4 with 1 on one of the die. would be what? There's 12. 12 over 36 minus, what's the probability of rolling a 10 with a 4 on the die? Two over 36. Does anyone have any questions where I got those numbers from? Okay, so when I do the math here, 15, 13 over 36. That's your probability.